In the previous video, we explained what is the aldehydes and ketones, and we started doing nomenclature. Remember that if you have more than one functional group, you need to determine what functional group will have priority to determine the main chain. Here with the analysis in this molecule, in the ketone has higher priority over the hydroxyls, over the alcohol functional group, say. So we determine that the longest chain containing that functional group, ketone, has 8 carbons. So it is an octanone, but it's 3. The carbonyl is in carbon 3, so it's 3 octanone. And then we need to specify the substituents. Remember that when you number also, you need to give the lowest numbering possible to that functional group. So that's the correct numbering, because if you started down here, it will be 1, 2, 3, 4, 5, 6 octanone. That would be incorrect. Next, we analyze what were the substituents. And we have one substituent in carbon 4 with 1 isopropyl. And in carbon 5, we have a hydroxyl group. We need to list alphabetically. So the iso prefix you do take into account when you're listing. So it is 4-isobutyl 5-hydroxyl, 3 octanone. But there is a chiral center. And here you need to determine the absolute configuration to complete the name. So elements of a stereochemistry are preceding the name. So I'm going to be doing this too also, but I'm going to change the structure just a bit because I want to add more elements of stereochemistry. Okay, so let's keep that in mind. Again, this molecule is a ketone here, alcohol alkene. So what has higher priority? Again, the more oxidized group here, the ketone, will have higher priority. So I need to number the chain. The main chain is this, so that I give the ketone the smallest number possible. So it will be this from here to here, not the other way. So let's do the numbering. It will be 1, 2, 3, 4, 5, 6, 7, 8, and 9. So now I have, if I didn't have the alkene, it will be 2, nona, non, no, on. I don't like that. I'm gonna stop that right there. I'm gonna stop it because I'm gonna chop that video. Okay, so if in the alkane would never with 9 carbon is nonane, but it's nonone if it is the ketone. But where is that? The ketone is in carbon 2. We say 2 here, but this is without including any other functional group. Here we have an alkene and we have an OH. So I am going to include in the name. Notice that the alkene starts in 7, so I'm going to say 7 in 2, non, and I have in carbon 5, I have a hydroxyl group, and I also have a methyl group in 7. So in substituents, I have a hydroxyl and a methyl group. So hydroxyl listing alphabetically goes first. So I'm going to say 5 hydroxyl, 7 methyl. So 5 hydroxy, 7 methyl, 7 into nonone. Okay, but there is a chiral center, and also I need to determine the configuration of the alkene here. And so the chiral center configuration would be then priority 1 is at the chiral center is this one. So highest priority is the OH. Then the hydrogen is in the back is your lowest priority. Then between what is attached to this center, so carbon 6 and carbon 4, their CH2 look the same, but if moving to another layer out, the 7 is more substituted than 3. So we're going to go, highest priority is the OH. Then we're going to go to the right and then this way. So it is R. Now let's determine, so it is 5R, but I still need to say what is the configuration of the alkene. So let's write here 5R, and the alkene starts in 7, but I need to say where there is E or Z. So here again, you need to consider the priorities. At carbon 8, we have an H and a metal. So highest priority is the metal. So I'm going to do that. Metal is higher priority than H. And on the other carbon, this carbon here, you have a metal and the side chain. This chain has higher priority over to the metal. Notice that the two highest priority are opposite sides. So this is A. So I'm going to say 7E, and the whole name then now is complete. I have the elements of stereochemistry. I have specified the substituents. I'm missing an L here, is metal. And I have specified the location of the double bond, and the main functional group is the ketone. Okay, so now let's work on our last example here. Let's erase this because we need a little bit more room. Now, again, you have, it's not an alkyl halide in this molecule. The main functional group is the aldehyde. And what is the main chain that contains the aldehyde? How many carbon it has? It has 1, 2, and 3. This is a bond between 3 and the final. So naming that, it is an aldehyde with 3 carbons. So that would be, prop is the prefix, so propanol, right? And in carbon 3, we have 2 substituents. One substituent is phenyl and the other is chloro. So by listing alphabetically, chloro goes first. So I need to say 2-chloro, and then 3-phenyl propanol. And I'm not done yet because there is a chiral center. So I need to assign the configuration, and this is carbon 2. So what is carbon 2? Again, you need to assign your priorities when you're doing that. The highest atomic number is the chlorine. And remember that here you have an H, but this time the H is on the wedge, meaning that I'm looking at this molecule opposite. So the lowest priority group is towards my view, not away from my view. So I will need to invert that. So highest priority is the chlorine. Then between this carbon and this carbon, the carbon number 1 has higher priority because it is attached to 2 oxygens. Carbon number 1 is attached to oxygen, and a hydrogen in the aldehyde. Carbon number 3 is attached to, notice, carbon. So this is higher priority. So if I do that, then second highest, I will do 1, 2, and 3. This way, it looks like S, but I'm looking at that the opposite way. So this is R. So the complete name will be then that. So what are the steps as usual? If you have more than one functional group, pay attention and determine what is the main functional group. In the case of the examples that we had, the functional group is either the aldehyde or a ketone that had higher priority, because aldehydes and ketones have higher priority over the alcohol. and that over the alkene. Now, there is for comprehensive list of all the group priority in the IUPAC. You can find that. But at least as a rule of thumb, as I mentioned before, more oxidized functional carbon, for example, carboxylic acid, will have higher priority over aldehydes and ketones. And aldehydes and ketones higher priority over alcohols. And that higher priority over alkenes and alkynes. So with that in mind, assign your main chain, keeping that the functional group, the main functional group needs to be in that chain, and assign the lowest number possible. That's what we did here. Main chain had the 3 that contain the functional group. And then you identify substituent, in this case was chloral and phenol, list alphabetically, and add the elements of stereochemistry. Similar strategy that what we did here. Your functional group is a ketone, but you also have an alkene and a hydroxy, which we need to say where they are. All the location of that. Elements of stereochemistry are always listed at the beginning. You had a chiral center in carbon 5, and the alkene also needs to be determined the configuration. In this case, you had the 2 highest priority here is on one side. Highest priority is this side versus that side, so opposite sides. The highest priority is the configuration.